Hello and welcome to the Half-Blood Prince channel, and today we're going to be talking about the Chatelier's principle and how we use this principle in chemistry to determine in which direction will the equilibrium of a reaction shift towards. And we'll start off with the principle's definition, and the definition is: if a dynamic equilibrium is disturbed by changing conditions, the position of the equilibrium moves to counteract this change or the change. So basically, a dynamic equilibrium, um, a reaction is in dynamic equilibrium, rather reversible reaction, when there is no net change between the products and the reactants of that reaction. So basically, now we will consider certain changes that we can induce in a system in order for us to determine how the Chatelier principle works and how we can use this to see what happens to the equilibrium when we induce those certain changes. And the first change is a change in concentration of the substances, obviously. And let's suppose we have these four substances A, B, C, and D in the following ratio. And let's just suppose we increase the concentration of A in this scenario. So basically, when we do that, the equilibrium will shift to the right, because since we have increased the concentration of A, the system will react in such a way that A's concentration will have to decrease again, and it will do so by reacting A with 2B so that more C and D are formed, so that the concentration of A decreases again. And obviously, when we decrease the concentration of A, this reversible reaction will shift more towards the left hand side, towards the backward reaction. So that means C and D will react a lot more in order to form A and 2B, so that this decrease in A is counteracted again but with an increase in A, and that can only happen when C and D react. Right, then that was the concentration factor. And the other factor that we can change in a system is obviously the pressure of the system, and this only applies to gaseous reactions or reactions with gases, because basically the definition of pressure is when gases exert the molecules of gases exert forces on the walls of a container. So all other states will be irrelevant when we do change the pressure of a system, right? So again, we have these four substances in their gaseous states, and let's just assume we increase the pressure in this system. But before we do try to figure out what will happen to the equilibrium, let's just notice that there are three gaseous molecules on the left hand side, because B exists with a double ratio to A, because there's 1A and there's 2B here, obviously, and on the right hand side we have two molecules of gas. Right, so basically, if that means that these three molecules of gases will exert more pressure than the two molecules here on the right hand side, obviously because there are more molecules on the left hand side. So when we do increase the pressure in a system, the equilibrium will have to shift to the right, because there are two molecules in total on the right hand side. That in turn would lead to a decrease in pressure, because two molecules of gas will obviously exert less pressure than the three on the left hand side. So basically the reaction will shift to the right. And as you've probably figured out by now, if we decrease the pressure, the equilibrium will shift towards the left because there are more gaseous molecules in the backward reaction of this reaction. So it will shift towards the left in order to compensate for the decrease in pressure, in turn to increase the overall pressure as the principle says, to counteract that change in the decrease in pressure. Right. And now the third factor that we can influence or change in a system is obviously the temperature of a system. But in order for us to use this principle, we will have to know, or it has to be a given to us, whether the forward reaction is an exothermic reaction or an endothermic reaction. And in our scenario, it's an exothermic reaction. So what basically that means is when the reaction goes forward, when the reaction goes to the right hand side, more heat will be given out, or in this case 250 kilojoules per mole of heat energy will be given out on the right hand side, and the backward reaction will have to be an endothermic reaction, which means the same amount of energy will have to be absorbed from the system, and that would obviously lead to a decrease in temperature because heat energy would be absorbed as opposed to heat energy being given out when the reaction goes forward, hence the negative sign. Right. Now, as you can see, when we will increase the temperature, the reaction will shift towards the left because the backward reaction, or the reaction towards the left, will have to be an endothermic reaction, and that would mean that this would result in an overall cooling of the system. Right. And when we do decrease the temperature in the system, the system will react in such a way that the temperature would have to increase, and that can only happen when the reaction will be exothermic, and in our case that is towards the right hand side, and hence the equilibrium will shift towards the right. Now then, those were basically three changes in conditions or factors, and the fourth point that I have isn't really a change in condition to say, but it's basically when we do add a catalyst, and it's important to know that adding a catalyst makes absolutely no difference to the position of equilibrium, and the Chatelier Principle doesn't apply to them because because a catalyst speeds up the forward and back reactions to the same extent. So even if you do add a catalyst to these conditions, it won't shift the equilibrium, because why would it? Because both the backward and forward reactions would be accelerated because of the catalyst. So the catalyst won't have any influence on the equilibrium. So basically, that was my take on the Chatelier Principle. We have these varying conditions, and basically the main gist of the principle is that the system will always react in such a way to counteract the change in the system that we've brought. Right then, I hope this tutorial was helpful. Please let me know in the comment sections below what other topics would you guys be interested in, whether it be from biology, chemistry, and physics, and I'll definitely make a video. Thank you, and until next time.